This is an example of a bearings type question. So here we have an aircraft carrier leaving a harbor. Its bearing is north 37 degrees east, and it stays on that heading for 23 miles. It takes a left-hand turn 90 degrees counterclockwise, travels for another 9 miles, and then it has to come to a complete stop so the first officer can come aboard, or you can think of it as the first officer knew where they were going to be, and we want to find out what direction the first officer had to travel and how far he had to travel to get to the carrier at that point. So, first off, when we talk about north 37 degrees east, there's only two main directions according to bearings that we're going to talk about. The main directions are north and south, so that would go in that first spot. Now, if we're going north, we're going to either lean towards the east side or lean towards the west side. So here we're leaning towards the east side by 37 degrees, and that's all this means. So this 37 degrees is measured off the y-axis because it's off of north. And we're going to draw a picture of all of this. So all I have to do is remember northeast, 37 degrees, 23 miles, and a 90 degree counterclockwise, and 9 miles. So we might have to come back to this problem. So let's draw it first. Where is it? Oh, I'm on it. All right. So let's draw a coordinate system. That should be good. And that should be good. So the positive x-axis is east, the positive y-axis is north, the negative y-axis is south, and negative x-axis is west. So what we're doing is we're traveling, get this out of the way, 23 degrees east of north. So we're moving in this direction. So this, I'm sorry, 37 degrees, if I remember right. Yeah, 37 degrees. So we're going to be traveling in a direction like, well, I'm going to bring it a little shorter. Make it a little more ugly. All right. So let's say that's 37 degrees right in there. So we're going to be traveling 37 degrees for 23 miles. So this will be 23 miles. Is it 23 miles? Yeah, 23 miles. So this is 23 miles. And the angle to here is 37 degrees. So this is 37 degrees. So this is north, 37 degrees towards the east. All right, and then at this point, after he travels the 23 miles, he's going to take a left-hand turn counterclockwise in this direction. So he's going to counterclockwise 90 degrees and shoot off in this direction. So if we do that, we're going to start here and go off in this direction. He's going to travel, it looks like a right angle, another 9 miles there. So this is 9 miles. Now what might get confusing is a lot of people think this 37 degrees is inside this triangle, and it's not. It's actually just part of the angle. So you got to be a little bit cautious with this part. So this is the side we're interested in, the distance and the bearings of the first officer, the red line. And notice the red line is cutting 37 into two parts. So some of it is inside the triangle and some of it is outside the triangle. So we have to be careful. What we're going to be looking for, get rid of this, is a very small angle inside the triangle. We're looking for this angle, a little tiny one in here. So we're looking for what's the measure of this angle. And we're looking for the length of that side. Now the length of the side is easier. Orange. No, orange is boring. Green. All right. So if we're going to go for the measure of that side, it's going to be c squared equals a squared plus b squared. When we plug in our numbers, so we get the hypotenuse is equal to 23 squared plus 9 squared. So we're going to get c squared is equal to 23 squared plus 9 squared, 610. And therefore, when we square root both sides and type it in our calculator, we're going to get the square root of 610, which is about 24.7 miles. So the first officer had to get in that little boat and travel for 24.7 miles to get to the carrier. But if he just travels 24.7 miles in any direction, he might not get to the carrier. So we also have to attach to it what is his bearings. Now his bearing is going to be this measure, north to east. And if it actually 9 miles carries him into the second quadrant, we'll have to deal with that a little differently. All right, so how do I find the measure of an angle? Well, I need to find the measure of the red angle first, this inside the triangle type angle. So what function associates this angle, this side, and this side? Well, if this is the right angle, that's the hypotenuse. This side is opposite, this side's adjacent. So that would be tangent. So we're going to say tangent of the angle, we don't know what it is, I'll call it theta, is equal to opposite over adjacent. And to find theta, we're going to use tan inverse. So we're going to say tan inverse of 9 over 23. And if we type that in our calculator, in degree mode, make sure my calculator is in the right mode. It's not. All right, so we're going to go tan inverse of 9 divided by 23, which is 21.4 degrees. So the angle inside the triangle is 21.4 degrees. That's the measure of this little angle. We're looking for the measure of this angle. So this one plus this one must add up to 37. So if I'm looking for that one, all I have to do is a little subtraction. So 37 minus 21.4, and you get about 15.6. So this angle here, 15.6 degrees. And that's going to be our bearing degree. So we're still heading north, and we're still traveling a little bit to the east. So our heading will be north, capital N, 15.6 degrees east. So here's his heading, and here's how many miles he has to travel to get to the carrier at this point. And that's it.